In this video, we will be talking about definite integrals. So definite integrals can be denoted as the integral sign, which is a squiggly line, the lower bound a and the upper bound b, and in the integrand, we would have our function, and to close off the integral, you would write dx. And this is equal to the antiderivative, and you would plug in the upper bound minus the antiderivative, and you would plug in the lower bound. So let's do an example. So the first example, we have the bounds from 1 to 2 for the function x squared. So let's evaluate the antiderivative first. So the antiderivative of x squared is equal to x cubed over 3 plus c. So for our definite integral, you would essentially plug in the antiderivative, which is x cubed over 3, and you would forget about the constant. And then you would have to then plug in the bounds. So over here we have our antiderivative, and then we have our two bounds, upper bound and lower bound. So now let's evaluate the upper bound and lower bound. So the first, we will have to evaluate the upper bound, which is 2 cubed over 3 minus, now we have to do the lower bound, which is 1 cubed over 3. And now we would just evaluate this expression, which is 8 over 3 minus 1 over 3, which is equal to 7 over 3. And here will be our final answer. And to make this more visual, let's graph this out. So let's say we have our parabola like this, and then our bounds are from 1 to 2. So our bounds, so these are our bounds, so 1 and 2. And then we want to find the area from here to here, this area. And this area here will be equal to 7 over 3 and whatever unit squared you have. And this is the intuition behind a definite integral. So let's do another example. Let's say we have the integral from 0 to 2 for the function 3x plus 1. So first step, you would have to evaluate the antiderivative first. So the antiderivative would be, oops, let me write this down. So the antiderivative here will be simply x to the power of 2 over 2, and you will multiply by the coefficient, plus x plus c. This is our antiderivative. So here let's evaluate everything. So it would be 3 over 2 times x squared plus x, and you would forget about the constant because it is a definite integral, and we have our upper bound and lower bound. So let's just plug everything in. So let's first evaluate the upper bound, which is 3 over 2 times 2 squared plus 2, and then minus, now let's do the lower bound. So 3 over 2 times 0 squared plus 0. So you could see that the lower bound, since it is 0, all of this is equal to 0. And now we just have to evaluate the upper bound. So 3 over 2 times 4 plus 2. And this simplifies, and then the final answer will be equal to 8. And this is our final answer. So let's do a couple more. In our next example, let's do from 1 to 4. And then let's do 1 over x. So remember, the antiderivative of 1 over x is actually ln x. And then now we just write the bounds, And let's evaluate this integral. So ln 4 minus ln 1. And then ln 1 is equal to 0. So our final answer will be ln 4. In our next example, let's do the integral from 0 to 1, and the function would be e to the x. So remember, the antiderivative of e to the x is e to the x. And then now let's write our bounds. And then let's now evaluate the upper bound and lower bound to the antiderivative. So it would be e to the power of 1 minus e to the power of 0. And this could be simplified to e minus 1, because e to the power of 0 is 1. And here would be our final answer. In our next example, let's do the integral of cosine x. And then the bounds would be from 0 to pi over 2. Okay, so let's evaluate the antiderivative. So the antiderivative of cosine, it's simply sine. Then let's write out the upper bound and lower bound. And then let's evaluate the upper bound and lower bound. So sine pi over 2 minus sine 0. So we know sine 0 is equal to 0. And then sine pi over 2 is simply equal to 1. And 1 is our final answer. If you found this video helpful, please leave a like and subscribe to the channel. Thank you very much for watching.